Hello guys, welcome to another lecture on JEE Concepts, and in this lecture, which is lecture number 5 actually, we are going to study about Rainman concepts and problems. And believe me, just like the other videos in this playlist JEE Concepts, this video also will clear your concept on this Rainman problems from the root level. That is, after going through this lecture, you are never gonna face any problem regarding any kind of question on Rainman, no matter how difficult it will be. So let us begin. So first of all, again, the relative velocity concept, which I discussed in the previous video on swimming across the river. In this video also, the relative velocity concept is very much needed. So here, suppose a person is walking at say 5 meters per second like this. I'm just taking a case that a person, that is velocity of that man with respect to ground is 5 meters per second, that this person is walking at 5 meters per second. And when he walks at 5 meters per second, he is seeing that the raindrops are falling on him at an angle of 30 degrees with the vertical and in this direction like this. This is 30 degrees with the vertical and in this direction. So this is what velocity of rain with respect to man. That is, man is seeing this. So that's why this man has to hold umbrella in this direction like this, in order to not get drenched because of the rain. So the velocity of rain with respect to ground will be somewhere like this, and this will be the resultant. Why? Because again we are following this relative velocity concept, that velocity of rain with respect to man is equal to velocity of rain with respect to ground minus of velocity of man with respect to ground. So if you take this to the left, then you will be having something like this, that is equals to velocity of rain with respect to ground. And I said that this is nothing but resultant. So when you are like summing these two up, velocity of rain with respect to man and velocity of man with respect to ground, then you will get the resultant, which is velocity of rain with respect to ground. And this will be at some angle, either from here you can say alpha or some here you can say beta. So that will depend upon the question, that what angle is needed. And again, the same concept over here, that you don't need to actually sum this up with the usual formula of under root of a square plus of b square plus of 2ab cos theta. You just need to have the components in the x and the y direction in order to get the resultant or any other answer of the question. The next concept is, and this is a very important concept linked with the relative velocity only, that suppose I'm saying when the man is at rest, the rain is falling vertically like this. This is velocity of rain with respect to man when the man is at rest. So here you can also have velocity of rain with respect to ground because the man is at rest. Now suppose the man starts moving in this direction, then he will perceive the rain to be coming in this direction, not in this direction, because he is running in this direction. Okay, you need to be very clear about it, because when the man is at rest, the rain was falling vertically. So when the man moves in this direction, then the rain will not gonna come in this direction but in this direction. And similarly, if he starts moving with more velocity like this, then this rain will further go away. This is what basically, this is velocity of rain with respect to man. That's why it is changing. But the velocity of rain with respect to ground will never gonna change with respect to the velocity of man on the ground. Why? Because this is velocity of rain with respect to ground. This has nothing to do with the velocity of man, obviously. So this is the thing that you need to remember, and you can simply prove it by making the velocity of man 0 by taking a reverse component in this direction. So this is just a logical way of doing that, but I'm telling you that keep this in mind, always keep this in mind. So I think you got my point. Like when the velocity of man is 0 and suppose the rain is falling vertically with respect to man because he is at rest, then when the man gains velocity, then the rain will also move in this direction like this, then this, then this. It will just increase this angle theta from the vertical. And suppose I'm saying that when the man is at rest, the rain is falling in this direction. Then after the man gains velocity, then the rain will have this kind of angle with the vertical from this vertical. Then after, if the man increase further velocity, then the rain will fall vertical. Suppose over here, then it will go like this, then like this when the man increases his velocity. So this is the way how the velocity of rain with respect to man will going to change its angle when the man increases his velocity. So this is the thing you need to remember. This will make the question very easy for you. Now another concept is wind concept. Well, you will find very less questions related to this concept, wind concept, but you just need to keep one thing in mind. When there is wind involved and it is given that velocity of rain with respect to wind is something, say 10 meters per second, then this is now the velocity of rain with respect to ground. You need to perceive it like this. So this is the only thing that you need to care while solving the wind concept problem, that the velocity of rain with respect to wind, if it is given as 10 meter per second with some direction, say vertically downwards, then suppose a man is moving in this direction with the velocity of 5 meter per second, and the wind is also blowing in this direction with a velocity of say 30 meters per second. It's very huge, I know, but let's just take an example. So before, when the wind is just blowing at 30 meter per second, then the velocity of rain with respect to this wind is 10 meter per second in this direction. Which direction? That is vertically downward. Now when the person starts moving in this direction, say 5 meters per second, then either this direction or this velocity is not going to change. The only thing that is going to change is the resultant and the perceived velocity in this direction. The perceived velocity in this direction will be what? 30 minus of 5, that is 25 meters per second. And with respect to that, we are going to find the resultant. This direction and this direction, so resultant will be somewhere in this direction. Okay, so we need to proceed like this. So this is basically the wind concept, that the relative velocity of rain with respect to wind is actually the velocity of rain with respect to ground. It is not going to change. You need to perceive it like that. So now let us move towards the question. So the first question is taken from the H.C. Verma book, example question actually, that a man running on a horizontal road at 8 km per hour, a man, suppose this is a man and running in this direction, which is 8 km per hour, finds the rain falling vertically. Okay, at this speed is find that the rain is falling in this way, that is vertically. So this is what velocity of man with respect to ground, and this is velocity of rain with respect to man. So the resultant will be somewhere over here. This is what velocity of rain with respect to ground. Okay, now he increases his speed to 12 km per hour like this. Now his speed is 12 km per hour. So obviously, as I said, if at 8 km per hour, if this was vertical, that rain was falling vertically downward with respect to this man, then when this man increases his speed to 12 km per hour, then it will go like this. And it will make some angle with the vertical, say theta. Okay, and finds that the drops make angle 30 degree with the vertical. So this theta is already given, that is 30 degrees. Find the speed and direction of the rain with respect to the road. VR with respect to G, that is ground, we need to find, and the direction too we need to find. This vector we need to find. So this is what velocity of rain with respect to man. In this case and in this case, these two are basically different. These are not going to be same, because this is with respect to man and the man's velocity are different in these two cases. So let us write this as 1 and this is 2. You need to be very clear about that, because in exam it's very natural to commit mistakes like this. If you're going to write VRM, both over same, then while writing the equation, you're going to equate these two to the same variable, and that is where you commit mistake. But other thing is, like here, the resultant will be somewhere here, velocity of rain with respect to ground. Now this velocity of rain with respect to ground and this velocity of rain with respect to ground, this both will be same. Why? Because velocity of rain with respect to ground is never going to change. So the direction and the magnitude both is going to be the same in these two cases, but not VRM. So now let us proceed. Well, if we know that these two are going to be same, so let us take this in the vertical direction and in the horizontal direction. So here it is VRM2, theta is 30 degrees. So we need to divide it into the two components, one component over here and the other component over here. So this component will be equal to the vertical component of VRG, and this minus of this component will be equal to the horizontal component of VRG. Let us see what I am saying. VRG vertical, that is vertical component, I am writing V in this direction. That will be equal to what? This VRM to this one cos of 30 degrees. Now in the horizontal direction, 12, this 12 minus of this VRM2 sin 30 in this direction. That's why I'm subtracting it from 12. VRM 2 sin 30, and that is equal to what? This minus of this, that is VRG in horizontal direction. But from here you can see that VRG in the horizontal direction, like from here, it will be 8 km per hour, the component of VRG in the horizontal direction, and this is VRG in the horizontal direction. So let us write this as 8. So this will be what? If you solve this, this is nothing but 12 minus of VRM 2 sine of theta that is 30, that is equal to 8. So this will be 12 minus of 8, that is 4, is equal to VRM 2 sine theta is nothing but half. So from here VRM2 is what? That is 8. VRM2 is nothing but 8. So just put that VRM2 value, which is 8, over here. Then we will get VRG vertical component as 8 cos 30. That is 8 into root under 3 by 2, which is nothing but 4 root 3. Because 2 times 4 is 8. So now we get the vertical component of rain with respect to ground, which is what? This 4 root 3. And horizontal component we already know from here, that is velocity of rain with respect to ground. Horizontal component is this 8 kilometers per hour. That is VRG. Horizontal is what? 8 kilometers per hour. Okay, so that is the answer. How? We need to find the speed and direction of the rain with respect to the road. First of all, speed. So we know VRGV and VRGH, that is horizontal and vertical component. We just need to have under root of a square plus of b square. That is 8 square plus of 4 root 3 square. So that will be what? Under root of 64 plus of 48. That is equal to what? Under root of 112, and that can be reduced to 4 root 7 kilometer per hour. That is the speed. That is the magnitude of the velocity. Now regarding the direction, well, we now know direction of the rain with respect to road. So either you can have this alpha or you can have this beta. Let us have this alpha over here. Then this alpha having tan alpha is equal to this upon this. That is the horizontal component upon vertical component. So tan of alpha is equal to horizontal component, which is what? Which is this 8 upon vertical component, which is 4 root 3. So that is equal to 2 upon root 3. Or I can say from here, that is cot alpha is equal to root 3 by 2. This. So alpha is what? Alpha will be equal to cot inverse of root under 3 by 2. That is the answer. So the magnitude is 4 root 7 kilometer per hour and the direction is cot inverse of root 3 upon 2. So this is the answer to this question. So see, you just need to proceed with the question. Just apply the relative velocity concept and whatever I have told, and you will finally get the answer. It's very easy, but you need to be very clear about the velocity component phenomena, like how to utilize this velocity components in the horizontal and vertical direction. So you need to be very good at it. Just practice it. Now let us move towards the next question. So the next question is like a man moving with a velocity of 5 meters per second, as shown over here. This 5 meters per second on a horizontal road observes that raindrops fall at an angle of 45 degrees with the vertical. This is actually 45 degrees, not 450, and this is 30 degrees, not 300. Okay, this is 45 degrees and this is 30 degrees with the horizontal. So this is actually given as 45 degrees. Now remember here that this man's velocity is 5 meters per second in this direction, and the rain is falling in this direction when the man is running at 5 meters per second, and this is 45 degrees actually, or this, because this is 90. So here it is already given in the question from the beginning. It's not like this 45 degrees. You need to be very clear about that. It means that at 5 meters per second he has to hold umbrella like this, not like this. Okay, now when he moves with a velocity of 16 meters per second along an inclined plane, which is inclined at 30 degrees with the horizontal, like given over here, when this man runs in this direction at velocity of 16 meters per second, then he observes raindrops falling vertically downward as shown in the figure, like this. Vertically downward he observes while he was traveling at a velocity of 16 meters per second at an angle of 30 degrees from the horizontal. Find the actual velocity of the raindrop. We need to find velocity of raindrop with respect to ground, that is actual velocity. So again, this velocity of rain with respect to ground will be same in both the cases. So this is the first case when this velocity of rain with respect to man given, and this is velocity of man with respect to ground. So somewhere over here our resultant will be, which will be velocity of rain with respect to ground. Okay, and the second case is this, like I'm continuing from this side, this is somewhat 30 degrees and rain will gonna fall vertically downward like this, and this is basically given as 30 degrees. So this will be what? 60 degrees. Okay, and this is velocity of man with respect to ground, that is 16 meters per second. and this is velocity of rain with respect to man. Let us write this 2 and let us write this 1 again. So here also the resultant will be somewhere, say here, velocity of rain with respect to ground. This is not going to change. The direction and the magnitude both must be the same in both these cases. So again I will apply the same thing like VRG V and VRG H, like the vertical and the horizontal components. So first of all consider this, then from here V actually vertical component, that will be equal to what? Contributed by this only, because this is completely horizontal. So that will be VRM 1 cos of 45 upon root 2. Cos of 45 and sin of 45 are same, that is 1 upon root 2. So this is the vertical component. Velocity of rain with respect to ground vertical component is what? This cos of 45. And the horizontal component will be what? VRGH. Horizontal component will be this, like VRM 1 upon root 2 again, this direction, because cos 45 and sin 45 are again same, this direction plus of 5, that is this velocity. So this is horizontal component and this is the vertical component. So that is the first case for the case of this. Now for this case I can have VRGH, that is horizontal component, is the component of this only, because this is vertical, that is VMG cos of 30 and VMG is 16, so 16 cos of 30, that is the horizontal direction. And VRG V will be what? Vertical component will be the summation of both these two, that is VRM2 plus of this VMG sin of 30, yeah, that is 16 sin of 30. So this plus this, that is equal to VRG V. So these two things we have, like this and this. Now let us see what can we do to find the actual velocity of the raindrops. Well, first of all we directly know VRGH, that is horizontal component, which is 16 cos 30. So this can be equated to 16 cos 30 directly. So let us write that. So now we can find VRM1 from here, and that will be equal to what? Or VRM1 upon root 2 only. Why? Because if you find VRM1 upon root 2, then this is what? VRM1 upon root 2 only, and so we will find the vertical component of the velocity of rain with respect to ground just by finding this. So this is what? 16 root 3 upon 2 minus of 5, that will be equal to 8 root 3 minus of 5. Okay, so this is what? VRM1 upon root 2, and this VRM1 upon root 2 is nothing but VRG vertical component that we have already seen from here. This VRG vertical component is VRM1 upon root 2. So this is what? This is 8 root 3 minus of 5. So now we know the vertical component of velocity of rain with respect to ground and the horizontal component of velocity of rain with respect to ground. Horizontal component of velocity of rain with respect to ground is what? 16 root 3 by 2, that is 8 root 3. So horizontal component is basically I cap and vertical component is basically j cap. But this vertical component of velocity of rain with respect to ground is in the negative y direction. If I am taking this as x, this is y, then this will be negative of y. So that's why I am writing it as minus of j cap. So the answer will be, like, velocity of rain with respect to ground will be 8 root 3 I cap minus of 8 root 3 minus of 5 j cap. That is the answer to this question. So again, the first question and the second question, the concepts are similar, but the way of asking the questions are completely different. Here the man is moving on an inclined plane which is inclined at an angle of 30 degrees, but in the first case that was just simply a straight line. So you just need to follow the questions and apply the velocity components phenomena, like you need to divide the velocity into the components and equate it to the already given variables in the problem in order to find the final solution, whatever the angle or the magnitude of the actual velocities, all those things. So now moving towards the third and last question of this video. So the question is, like, rain is falling vertically with a speed of 20 meters per second relative to air. Okay, it means that this rain is just falling this vertically 20 meters per second, and this is what? Velocity of rain with respect to wind. And as I have told that this is going to be the same, no matter the velocity of the observer. Okay, just like here a person is running in the rain with a velocity of 5 meters per second. Okay, this is what person is running at a velocity of 5 meters per second, and wind is also blowing with speed of 15 meters per second, both towards east. So this is what wind at 15 meters per second, and both is towards east. Let us assume this direction as east, from west to east. So find the angle with the vertical at which the person should hold his umbrella so that he may not get drenched. Okay, so when the wind speed is just 15 meters per second and the person was not moving, that is without taking care about the person, then the velocity of rain with respect to wind is 20 meters per second. And even if the person is moving, like in this case, then also the velocity of rain with respect to wind will be same, that is 20 meters per second, as I've already discussed in the beginning of this video. But here, when the person is moving at 5 meters per second, the perceived relative velocity will be what? That will be 15 minus of 5 in this direction, that is west to east. That will be equal to 10 meters per second, west to east. Now with respect to this new velocity 10 meters per second and this already velocity of rain with respect to wind, that is 20 meters per second, the resultant velocity will be somewhere in this direction, and that person needs to hold his umbrella in this direction like this in order to not get drenched. And we need to find that angle with the vertical, that is this angle theta. So what will be theta? Well, tan theta will be equal to, this is 10 upon this is 20. So this is equal to half. So theta will be equal to tan inverse half. So this is the answer. The man needs to hold his umbrella in this direction, tan inverse half with a vertical. So this is how you need to do this kind of questions where wind is also involved. That is, don't need to change the velocity of rain with respect to wind with respect to the velocity of man on the ground like this. This will always be the same as I have discussed in the beginning of this video. And with respect to that, the resultant velocity is going to change. This is basically the resultant velocity. And the angle was what? Tan inverse half. So this is the answer. So this is it about this video, guys. I hope you got my point. And after going thoroughly through this video, you will never gonna face any difficulty in doing any kind of questions related to the man and umbrella. And even now, if you face any difficulty, any problem in doing any kind of questions related to this topic, then feel free to contact me. The link is given in the description below. So till then, thank you.